All right, we are back, and today we are finishing off these notes, and we're going to be looking at 8-4, more two-step equations. We did this previously, and now we're going to the back side of the notes. On the back side, we are going to revisit how to solve an equation. But not only are we going to revisit it, we're going to do an investigation of the inverse operations. So you can see that we have three categories. We have most direct route, which we learned in a previous lesson, the longer route, and one of many absurd routes or routes. So let's take a look at the most direct route. You guys remember this. We would locate the variable, and I was classically highlighting the variable in yellow. And then we would know that it has a coefficient, and we would also know that there is a constant. You also know and have learned that when you see a subtraction sign, we like to use the additive inverse. Now, when you use the additive inverse, it makes things easier. So we learned in the last lesson that we want to deal with the constants first. So to remove adding -5, we're going to add a +5 to both sides. And remember, the sides of an equation are split with an equal sign. So then we draw that line, and we go 2n is equal to -17 plus a +5 is -12. And then we deal with the 2 in front of the n. So we divide by 2 on both sides, and we get n is -6. And that's called the most direct route. Let's take a look at doing it a different way, with taking a longer route. We're still going to use additive inverse, and we still see that there is a variable to be solved for, and it still has a coefficient, and it still has a constant. Now, typically in the direct route, we would deal with the constant first, but this time we're going to deal with the coefficient first. And so we are going to divide. We want to get rid of the multiplying by 2, so we're going to divide this side by 2. Now you have to divide the whole entire side by 2. And you know that property of equality, if you divide one side by 2, you have to divide the other side by 2 to keep it equal. All right, let's move on. This says 2n divided by 2 plus -5 divided by 2 is equal to -17 divided by 2. So 2 is dividing everything on the left side. Let's sharpen this up a little bit. 2 divided by 2 is 1, and so n is by itself. And now we need to get rid of the constant of -5 halves. To get rid of -5 halves, we're going to add a +5 halves to both sides. And this, as you know, is a 0, and n is by itself. And -17, well, wait a minute. Our denominators match, so we're free to add the tops. -17 plus 5 is -12 halves. And -12 divided by 2 is -6. And look at that. We have the same answer. But look all of the extra work we had to do to get the same answer. So is that the most direct route? No, it's more work. But does it work? Yes. All right. Now let's look at one of many absurd routes. Absurd. Underlined absurd. All right. So what I would like you to do is put -1 right here and put parentheses. And then put an equal sign and then a -1 and then parentheses. Now you can see I'm using the property of equality and multiplying both sides by a negative. And so I'll put 2n minus 5 in here and -17 in here. Now, am I treating both sides equally? Yes. By multiplying both sides by a -1. Well, why would I do that? Well, I can see that when I use the additive inverse here, I have a few negatives in this problem. And I was just thinking, if I multiply those negatives by a negative, it turns them into positives. So that's what I'm going to do. Because I'm thinking if I can get rid of negative signs, it might be easier. So a negative times a negative is a negative times a positive is a negative. And this negative times this negative is now a positive. And this negative times this negative is now a positive. And it worked. I turned my 5 and my 17 both into positives, but now my 2n is a negative. All right, that's fine. So what am I going to do next? Well, next, I'm going to look at the 17. But before we move on, a student in my class caught this mistake. This is supposed to be an equal sign. So thank you for calling out that mistake. All right, so let's remove the 17 from the right side, which is a real unusual move. And to do that, we add a negative 17 to this side and a negative 17 to this side. Now that seems like a strange idea to do, but we're treating it equally on both sides, so let's continue. This is now going to be negative 2n plus 5 plus negative 17 is negative 12 is equal to 0. Well, we're not getting any closer to the answer, but we are using the properties of equality. So let's move the negative 2n to the other side by adding a positive 2n to this side and a positive 2n to this side. Now we have some success here because we move the 2n to the other side, and now it's positive because we added 2n to both sides. All right, now I'm going to divide by 2 on both sides. And I'm going to get n is equal to negative 12 over 2. And that is negative 6. So you can see what's happened here. Well, we used the property of equality here to both sides. We used it here to both sides. We used it here to both sides. We used it here to both sides. So really, you can make these as long as you want. And you can do really crazy things to both sides, but it doesn't matter because you're treating both sides what? Equally. All right. So which one's the best to use? Well, if I were you, I would be using the most direct route. All right, let's get down here to today's lesson. We got these two boxes. They're not going away. Use the distributive property, combine like terms by using the commutative property of addition. Then move down to the third thing, add and subtract the constant, and then the fourth thing, multiply and divide the coefficient. That's the most direct route. Let's try these things out. Well, number 1. You know I like to do the additive inverse on all subtraction signs. So we're going to do that first. So additive inverse will help us here. And negative 2 is multiplying all the terms inside this group here. We've already learned about the distributive property, and now we're using it again. And now you can see we have our variable, and that variable has a coefficient, and it has a constant next to it. We know that the most direct route is getting rid of the 20 first by adding a negative 20 to both sides. And that gives us negative 2x is equal to negative 2. Well, then we divide by negative 2 on both sides, and x is 1. Remember, you can always take your answer and substitute it back in for x. Let's try it. 1 plus negative 10 is negative 9, and negative 9 plus negative 2 times negative 2 is positive 18. On to number 2. Additive inverse. The 2 is now on the back side, but there's no sign between the parentheses and the 2, so we know the 2 is multiplying everything inside the group. So we'll do this and this, the distributive property. 1 5/10 x times 2 is 3x, and negative 15 times 2 is negative 30. We'll bring down the plus sign. We'll locate that variable. We'll see there's a coefficient and a constant to deal with. Let's take care of the constant first. We'll add a positive 30 to both sides. Now line up the decimals so it makes it easy on you. And 3 3/10 plus 30 is 33 3/10. And now we're going to get rid of the coefficient by dividing by 3 on both sides. And x is, this is a mental math problem right here, 33 3/10 divided by 3 is 11 1/10. Now you may use your calculator on something like that, but I'd like you to be using your brain. It's faster than calculators. Number 3. Do you see any parentheses? There are none. But we do see a subtraction sign, so we use the additive inverse. And when we have all addition signs, we can use combining like terms. We can add out of order. That's the commutative property. So we're going to put together negative 3t and 8t because they are like terms, and that's going to give us 5t's. And now we are set to identify where the variable is, find the coefficient, and find the constants. And the most direct route is to get rid of the constant. From here, it's time to get rid of the 5. So we will divide by 5 since it's multiplying. And on this one, t is equal to 3/5. And 3/5 is a fraction in lowest terms. It is simplified. So t is 3/5. Don't change it to a decimal, just leave it like that. Number 4, we got another subtraction sign, additive inverse. And 1/3 is multiplying everything inside the group. So here and here. 1/3 times x is 1/3 x. And 1/3 times negative 6, well, we know it's a negative answer because it's a positive fraction times a negative number. So it's negative. And if you can do that mentally, awesome. If you can't, you just have to go over here, make negative 6 into a fraction, and see that this is negative 6 over 3, which is negative 2. Bring down everything. Locate the variable. See that there is a coefficient. And also see that there is a constant. We deal with constants first. So we'll add positive 2 to both sides. And we'll get 1/3 x is equal to 13. Now it's time to get rid of the 1/3. Now we've learned how to divide by 1/3, but we know what happens when we do that to both sides. So we're not going to go and do that. We're just going to turn this 1/3 into the number 1 by multiplying it by its reciprocal. And that creates 3 over 3, which is 1, and 1 times x is x. So since we multiplied the left side by its reciprocal, we multiply the right side by its reciprocal. If you like, you can always turn any number into a fraction. And 13 times 3 is 39. Okay, moving on here to the next one. Finally, no subtraction signs to deal with, so we're going to move right into the distributive property. Catch this negative sign here. It's a negative 4 times the 1 and a negative 4 times 3y. So that's negative 4 plus negative 12y. We locate that variable. We see there's a coefficient and we see there's a constant. We deal with constants first. To remove the negative 4, we add a positive 4 to both sides. To remove the negative 12, we divide by negative 12 on both sides. And y is 16 over 12, but there's a negative sign here. So I like to raise it to the top. Now that's not the answer because it's not simplified. So the actual simplified answer is -4/3. And we leave it improper in simplest terms. Now we wouldn't want to write that as a decimal answer because you would literally never be finished. It'd be -1.3333, and you would have to write threes the rest of your life. So that's why we like fractions. And now finally, number 6. Number 6 has got a lot of things going on here, but let's look carefully what's happening. 3 is on the outside. It's multiplying everything inside the brackets. And inside the brackets, we got some craziness here. We have -n minus -5. But if we use the additive inverse, it makes it a lot simpler. It's -n plus 5. So let's distribute here and here. That's -3n plus 15. And then do we multiply this 3 times the n? We do not, because that n is not inside the group. We just bring it down. Now we have an addition sign and an addition sign, and that means we can use the commutative property and add out of order. Do you remember what's in front of this variable that you can't see? A 1, and -3 plus 1 is -2n's. And now we locate that variable. We see we got a coefficient. We see we have a constant, and off we go by adding a -15 to both sides. And you get a 0 on the right side, which seems like you did something wrong, but we didn't. So we're going to continue. We're going to divide by -2 on both sides, and n is 0. If you don't believe it, just put 0 right here and 0 right here, and you can see that 0 plus 5 is 5, and 3 times 5 is 15. So it is right. All right, those are your 6 examples, and now you have 3 to contend with on your own. Pause the video and try all 3. Pause now. All right, here are the solutions for 7, 8, and 9. 7 is pretty standard. 8 had some additive inverse in the beginning and distributing some negatives. But number 9 had a fraction. And I do want to mention this spot right here. This was -3/8 times 8. Now I did that mentally, but sometimes you're going to want to write it somewhere else on your paper, such as this. Make 8 into a fraction. And then you can cross cancel the 8s, and you can see that it is -3. So from there, I just moved on. I also made -6 into a fraction down here, so I could clean this up down here. 6 times 8 is 48, and 48 divided by 3 is 16. It's always important to put your first name, your last name, the date, and the period. And it's always important to read the directions. It says translate. Oops, this is not the right paper. This is our previous assignment. Let's go down here to this one. Here we go, 8-4. Sorry about that. First name, last name, date, and period. Solve each equation. All right, just what we've been doing. So 2 times x and 2 times 4. Get rid of the 8s. Now watch this. I'm going to subtract 8. I usually add a -8, but this works too, as long as you're doing the property of equality. 22 take away 8 is 14. We'll divide by 2, and x is 7. We'll go down here and look at the ones at the end to see if there's any difficult ones to do. 17 looks pretty standard here and here. 15, I have a minus sign, so I'll do that one. Additive inverse. I'll do these two as -4x plus 36 is equal to 32. We'll add a negative 36 to one side and the other side. And we get negative 4x is equal to negative 4. We'll divide by negative 4s on both sides, and x is 1. We'll shop for another one that looks like it might be difficult. 13 looks pretty easy. 11 has that situation here where the 2 is on the back. So we're going to go 2 times this and 2 times this. Oops, right there. And that's going to be 36 plus 2x is equal to 30. We'll add negative 36 to both sides. We'll get 2x is equal to negative 6. We'll divide by 2 on both sides, and x is negative 3. Remember, you can always check these to make sure you're right. Just put it back in. Let's take a look at number 5. 5 is similar to 6, and there's one other one with a fraction. So we're going to do additive inverse, always. Half times x is a half x, and a half times negative 4 is negative 2. Now, hopefully that's mental math for you, but if it's not, you just set it up on the side. Make your negative 4 into a fraction, and you can see that it's negative 4 over 2, and negative 4 divided by 2 is negative 2. We just write down everything else. We add positive 2 to both sides. And the half x is equal to negative 6. Now we have this half, so we're going to multiply by 2 over 1 on both sides. And then we get x is negative 12. Okay, we have a request for number 17. And 5 times x is 5x, and 5 times 12 is 60. So we'll add a negative 60 to both sides to take care of the constant. And we get 5x is equal to negative 40. Then we'll divide by 5 on both sides, and x is negative 8.